Hi everyone, welcome to Smart City Institute Japan's webinar series called Global Perspectives on Smart Cities. I'm Nagumo, Executive Managing Director of Smart City Institute Japan, your host of this program. And today, this is the second session with our friends in UK. And we had a first session on Monday, and this is the second one. And today's session is on the topic of evolution of smart cities based on neurons, nervous systems for sewers. And before inviting our distinct speakers today, just a little housekeeping message to the viewers today. And as always, we would like to welcome all of the viewers to send a message, questions through the chat box. And when you send us the message or questions, please choose all from the pull-down menu so that we can share all the writings with all the members attending the session. All right, so let's invite our distinct speakers today. First, Ms.Claire Fenwick, Managing Director, Nuron Limited. So Claire, please come in. Welcome.
Hello, thank you. I'm delighted to be here.
Hi, thank you for coming. The second person, Mr. Richard Lewis, SeniorTrade and FDI Manager, APAC Technology and Smart Cities Department for International Trade. Mr. Lewis, please come in.
Hello, and thank you for having me.
Welcome. All right. The third person, Mr. Phillip White, Technology Specialist, Department for International Trade. Mr. White.
どうぞよろしくお願いします。
はい、どうぞよろしくお願いします。Okay. So this is the second session with UK solutions. And it's going to be a very interesting topic today. It's about the sewers. And we have a lot of issues in infrastructures in rural Japan. So we're looking forward to listen to our presentation. So without further ado, let's move on to the first comment. Mr. Richard Lewis, please.
Thank you, Tag. The UK, it has a very, very long history of innovation and support of tech companies, and we have a lot of diverse companies that have solutions for smart cities. How did we arrive at this actual situation is that a few years ago, the UK government took the view that to help the industry develop, the government needs to look at providing the background and the building blocks that the industry can then develop solutions on. So what they did is they took the view that all public data was to be made available. That's obviously taking into account personal data protection, and also it was that they were to encourage industry and other people who have data to share their data sets, make them open, and also in a format that everybody could use, so a standardization format in a way. So the Open Data Institute was created to help this this process away. Moving forward a few years, this has resulted in a large number of UK companies that provide lots and lots of solutions for smart cities, because obviously making a city smarter helps the population live better, the city become more sustainable, and not only do we have solutions that help things like traffic and heating, cooling. There are lots of companies that help with the infrastructure and the management of the infrastructure, such as Nuron, which you will be hearing from shortly. Now, if you want to be connected to UK companies, then the Department for International Trade, myself and my colleagues in the British Embassy in Tokyo can help you. We have a couple of smart cities directories that are freely available that give you a snapshot of what's available. but do come and talk to us if you want to know more. So thank you, and back to you, Tak.
Thank you very much. Okay, without further ado, let's listen to Ms.Claire Fenwick's presentation. So Claire, it's your show time.
Okay, thanks. I'll just share my screen.
It's good?
Yeah, that works
Yes.
for you?
Yep.
Fantastic. Well, I'm really pleased to be speaking to you today. I have not visited Japan yet, but it's definitely somewhere that I really hope to visit very soon. I've got 2 young children, so I get a daily dose of sort of Pokemon and manga. But I've always been really fascinated with how sort of the traditional culture and values blend with a really modern tech, high-tech society. And I also have a massive love of Japanese food as well. So a little bit about my background. Before I started working at Nuron, I spent decades sort of improving operational efficiency, capacity, and resilience in long linear dendritic networks, but that was in the communications industry. And now I really want to do this in water as well. So my interest in sewers began when I was working within communications, and I was operating a commercially successful network that was built within the sewers in London. And now in order to operate a fiber network within someone else's asset, you really need to understand sort of and value and respect the job of the utility whose assets you're using. And that's where I learned a lot about sewer operations. The sewer is a great way to build cost-effectively networks within London. And we really wanted to get closer to buildings, and that meant going through smaller sewers. And working with water companies, they were not as keen for us to actually deploy fiber networks through smaller sewers. And they felt that the risks outweighed the small revenues that they were achieving for that. This business was sold in around 2017, I believe. And in 2014. And after that, we started to really explore what optical fiber could do for water companies, because we realized that actually most utilities in the world installed optical fiber for command and control, and not just as an additional revenue stream. And the concept of Nuron was formed. So today I'm going to share with you where this journey's taken me. So we're going to look at some of the challenges faced by the wastewater industry. We're going to look at what the current state-of-the-art technology is to mitigate these challenges. I'm going to tell you about our nervous system for the sewers and how it works. And then I'm going to go on and look at how wastewater networks can play a wider role within a smart city. So I thought I'd start by just telling you a little about wastewater infrastructure, just so that we're all speaking the same sewer language at least. So the main sewer is here, and that's usually connected to a wastewater treatment plant. The sections of sewer that tend to connect to a main sewer are called sewer laterals. The access chamber to allow you to operate and maintain the sewers is, I'm calling a chamber here. And then there are also manhole covers that cover those in the street. And I also thought I'd just touch on a combined sewer overflow for those of you that aren't familiar with sewer networks as well. So in good weather, a sewer would operate as normal, but sewers are designed with overflow points that where there are really extreme weather events, then instead of flooding streets and homes, the sewer is designed to overflow into rivers and seas. And you know, and that's what we call a combined sewer overflow. So while I was preparing for speaking at this event, I was researching some of the sewers in Japan, and I've become quite fascinated with sewers over the years. And I found that in Japan, as in most countries, they come in all sorts of shapes and sizes. And you get from the really, really old sewers that were built years ago. There's an example in Osaka Castle, to the really new cathedral-like storm sewers that have been built that are designed to take over 7,000 cubic feet of water. And here's an example of sewers in Kandahar as well, brick-built sewers. And these are some of the earlier sewers that were built in Japan as well. But my favorite new fun fact about sewers is drain spotting in Japan. So in Japan, it seems that you've elevated manholes into works of art, which I really, really like. And I hope that that's going to catch on in the UK as well. So 7 years ago, when we started to look at what monitoring and control there was in wastewater networks, here's a little bit of what we found. So the wastewater network was the least monitored and managed part of the water cycle. There was relatively good monitoring in wastewater treatment plants and water treatment plants. But there was and also along the pressurized networks, which are easier to monitor, there was reasonable monitoring there as well. However, sewers typically had a single parameter monitor within chambers around 155 kilometers apart. So just to put that in perspective, that's slightly more than the distance between Osaka and Nagoya, and slightly less than the distance between Niigata and Sendai. This has improved over the years, but not dramatically, and in my view, not enough. Customers are still reporting faults, and the root causes of exactly where the issues are found are really difficult to find and pinpoint. And so we found and felt that actually the wastewater data was the missing piece of the puzzle. And without this data, then a true real systems approach to water cycle management was really difficult to achieve. And this is becoming more and more important in water-stressed environments where actually wastewater is an alternative source to water. And we also found that climate change combined with increasing populations, aging assets and urbanization has been putting really significant pressure on our wastewater networks globally. And this is causing an increase in serious issues like flooding, water pollution, and water scarcity. And public opinion is also driving the fact that this really needs to change and is no longer acceptable. So what could water companies do to mitigate these issues? Well, sort of looking at the GCAN solution, we could build bigger sewers. And there are definitely cases where this is absolutely the right thing to do and necessary. However, there's a really high carbon and financial cost to this. And so we need a smarter solution. We could increase the density of spot monitors. And this has shown really good results in other parts of the world. So in North America and Canada, they've been deploying smart solutions there using the latest technology of spot monitors. And they have been able to improve water quality and reduce the spills by combined sewer overflows into their waterways and improve water quality, which is excellent. However, now that they've found that the data is incredibly useful, they're really struggling to actually scale this, because actually the data calibration and cleansing that's required and the cleansing of the monitors means that in order to increase the number of monitors, then they're also implementing another ongoing maintenance estate, which requires battery changes and is really challenging to maintain at scale. So an alternative could be low-cost discrete in-pipe sensors that need very little maintenance. And work is being done on this currently, but the real key challenges for underground assets is actually having reliable communications and power in order to operate these assets. So that's still work in progress, and I think will require quite a long development period going forward. And so another alternative now that we've been working on for the last 6 years is using optical fiber as a sensor. Now, this isn't new technology. This has been used in oil and gas, and I'll tell you a little bit more about that later. But we liken it to, and I apologize to any neuroscientists in the audience, but we liken it to a nervous system for the sewers. Here you can see a diagram of our sensory containment system, and in it it's got a sensing fiber in here that actually does the monitoring, and then ducts which are used for the communications of the system, and I'll tell you more about those later. And so the sensing fiber we liken to the nerves in our body, and the sensor monitors data continuously. And these sensing fibers sense the acoustic and optical changes within the sewer. And the interrogator, which is this, so I've realized I've been pointing at my computer and not the slides that you're looking at. This, the optical interrogator is here, and here is the sensory containment, and there's the sensing fiber that I've been talking about. The optical interrogator sits at the surface, and one optical interrogator can monitor over 200 kilometers of the system, and it acts a bit like the brain in our bodies as well. So here's a schematic of our system, and it's a dual purpose wastewater monitoring and fiber deployment technology. So here you can see the sensor, which is bonded to the base of the sewer robotically. It's really low profile and takes up less than 1% space occupancy in a 300 mil sewer. And it's designed to improve the hydraulic capacity there. The sensing zone, shown in yellow, has been specially designed to measure flow, depth, temperature, and structural integrity every 5 meters along the sewer. And the sensing fiber is just a common grade communications fiber. So it doesn't have any Bragg ratings or anything special like that, and it keeps it an affordable solution. The interrogator that's not shown on here actually sits at surface, and it can be located anywhere along the route where the sensor is. So that's anywhere along sort of 100 to 200 kilometers of sewer network. And so this means it could be conveniently located at a wastewater treatment plant or anywhere that has mains power. And so this one piece of equipment is mains powered, and it's the only power required to operate the system. And it also means that the system can be really easily upgraded. So you just need to upgrade the software, and that immediately upgrades the capability across the whole 100 to 200 kilometers of sensing. And then we have the communication zone here, that's the red. And so the communication zone holds microducts, which are small little tubes that allows fiber cables to be blown through it. And this communications platform provides a really reliable data platform to transmit all this monitoring data, but also any other water monitoring data and telemetry across the system. So why build fiber networks in the sewer? Well, where there are sewers, there are people, and obviously due to COVID-19, those people now need excellent connectivity at both work and home. In Japan, the fiber penetration is world leading. If in fact, if not, you may even be the leaders. But unfortunately, this isn't the case in many other countries. And using the sewers is a really sort of secure place to build fiber networks. And you can build them much more cost effectively and with minimal disruption compared to actually digging up the streets. And as I said, it's a really secure location, and it offers a resilient route to traditional networks that are built within the street, which can also be really helpful. So I'm going to talk about how it's installed. So here are some pictures from where we've installed it in a live sewer in the UK. The system is installed robotically, and this is our robot. We call it OSCAR, which is short for Optical Sensory Containment Application Robot. And it's installed modularly, so it's installed from one chamber to another chamber. And before we install, we inspect the sewer and make sure there are no issues. We jet the sewer, and then OSCAR will pull the sensory containment through, and then it cures it to the base of the pipe. And in order to install, at the moment, we currently flow stop the main sewer, but the customers are still able to use the sewer in their own home. It doesn't have to be pristine and clean for us to install. In this installation, we were installing in a pipe that was between 225 and 300 mil in diameter. And but the system's dimensioned to be able to install, and OSCAR can install in sewers greater than 300 mil. And we have plans to miniaturize this to 150 mil. And really, we're waiting for the use case to do that, but we know exactly how that will happen. And during our installation, we installed in sewers of grade 1 to 5. And so that, I don't know if you have a similar grading system in Japan, but really 1 means, very good condition, and 5 means a very bad condition. And here's a couple of examples. Here's a grade 1 example, and here's a grade 4 example type sewer. And so the installation system works really efficiently. There's a dwell time of about 2 to 3 hours per section that's installed. But once installed, it's got a life of 20 years. And at the end of each day, then the road is left completely clear. It's as if we've never been there. And we've also developed a removal system as well that can remove the sensory containment and return the sewer completely back to how it was if necessary. So I'm going to take a little pause and hand you over to my colleague, Paul Dickinson, who's our technical director. He has a background in distributed acoustic sensing and has worked previously in the oil industry on flow monitoring for gas and oil pipelines. And he's going to tell you about distributed monitoring and effectively how our system measures.
What is distributed monitoring? I've used the term in a number of these videos, and maybe it's time to unpack what we actually mean. Well, generally speaking, it's any form of monitoring where there are sufficient data points to give essentially continuous visibility. That's particularly useful for long, thin assets like sewers, water distribution networks, pipelines, etc. In our case at Nuron, it primarily refers to distributed monitoring using optical fiber sensing. To do this, we deploy optical fibers which we've configured as a sensor to maximize their response to the surrounding conditions. Into the optical fibers, we fire laser pulses from one end. Most of that laser light travels all the way along the fiber and comes out the far end. A small amount is backscattered all the way along the length and returns to the original point. By measuring the properties of this backscattered light, we can determine useful things like temperature, plus other things like strain and vibration. Working with the University of Sheffield, we've developed algorithms to convert those parameters into useful things like flow rate, blockage location, infiltration alarms, etc. Now, the really clever bit is that by time of flight, each laser pulse actually measures at many thousands of locations simultaneously on one fiber. And by firing many laser pulses, we get a continuous measurement. It's a great technology, but it also has a number of really practical advantages. The first one is that it's highly scalable, so it delivers dense data with multiple parameters, all time correlated across very large areas. That gives you no blind spots in your monitoring. Secondly, there's no power in the sewer. Now, this has a lot of advantages, but the key one is it means you don't need batteries. So there's no associated maintenance and there's no environmental footprint from disposing of those batteries when they're used. So, optical distributed monitoring gives you great visibility, really easy maintenance, and most importantly, it unlocks those smart networks that we all want to see.
Great, thank you, Paul. I'm going to now just tell you about the measurements that we saw on this live deployment as well. So our system, we were able to measure flow and depth. We were able to identify the location to within meters of blockages. Our resolution is 5 meters, but actually we were able to identify these to within 2 meters within the pipe. We simulated material dumping and could see clear signatures of that. We were able to see capacity constraints. So as this is an example of the sewer that we installed in, or a schematic. And you can see, whilst it didn't cause any issues, we could definitely see the impacts of the pipe, the smaller pipe going into the larger pipe, and the capacity constraints could be seen here. And we found signatures for chambers being opened and closed, which would be a good security detector. We were able to observe user behavior and infiltration, which is groundwater seeping into the sewers, and lateral inflows as well. So here is a schematic with laterals coming in, and we could tell when they were firing. So this graph shows a correlation of our sensing versus a spot monitor that was actually placed in this downstream chamber at the end. And there was a really excellent correlation with that. But the main difference is actually that we had 53 measurement points along that section versus 1 ultrasonic monitor. And the fact that we had 53 monitoring points along here allowed us actually to monitor the lateral inflows coming in, which gives another granularity of the visibility that you could see. So what we found from this additional monitoring here is that you could actually map residential connections. So you could understand which ones were rainfall only, which ones were domestic only, and which one had mixed use sewers. And then also you could monitor the status of the pipe. So if the behavior changed, you could understand whether there was an issue between the connection between the main sewer and people's properties as well. And also working with a water company, we also evaluated then what how cost effective this monitoring is in terms of, it clearly outperforms the current technology, but actually we found that over a 5-year period it was 97% more cost effective than the nearest available technology if it was deployed every kilometre along a network, which is still quite far apart. And so what are the benefits of a smart sewer then, and why would we want smart sewers or smarter sewers than we have today? Well, by being able to see all the way along the pipe and through the pipe, you can confidently, you can have real-time capacity management. And so this saves on CapEx and carbon. So you can confidently do more with what you have and replace grey solutions with targeted green solutions or smart solutions like in-system storage. And you can also proactively manage and maintain your assets, and things like H2S, which can eat away at the concrete, and it can extend the life of your assets, again, to deferring capital costs. It also then can deliver the operational data allows you to move to a proactive and predictive way of operation. And so by having visibility of what's happening in the network, then you can really reduce abortive visits, find issues immediately or to within meters, and proactive operations been shown to be at least 40% more cost effective and have a lower carbon footprint than reacting. And by intervening early, you can protect the environment from unnecessary spills. It will enable you to use less energy, again, helping move to net zero. You can implement demand side management, eliminate unproductive visits, and where viable, really remove unnecessary flows. But we'll be telling you where all of those things can happen. And so you can move to a mode of operation where you can deliver exceptional customer service while supporting at least 8 of the UN sustainability goals at the same time. And so how can this support Japan's interests? So Society 5.0 super smart cities want digitization of cities, big data and automation. Now our system's designed to be retrofitted into cities and into existing assets, making them smart. And it then delivers a brand new citywide data set that's never been seen before. And combined with other insights and intelligence, I think that it will be fascinating what actually you can learn from the way that sewers are operated. I think that potentially this technology could have a really big place in terms of COVID detection. So COVID detection of sewer systems has been talked about quite a lot, obviously during the pandemic, and has been very interesting. But using our system, instead of just understanding that there is a viral load in the sewer, potentially you can then start to understand where that came from by using the historical data that our system captures, and ultimately it delivers a real life digital twin at the same time. So climate technology, there's a real driver for climate technology and carbon neutrality. And so our system can drive operational efficiencies in the water networks and reduce the carbon footprint across the business. And it also improves water to reuse because it allows a true systems approach of management by providing, dense wastewater monitoring data. And that combined with the data on the clean water networks and the treatment plants will really help unlock that full circular economy potential. And I'll talk a bit more about that later. And as well as that, so smarter infrastructure is a requirement. And so our system enables infrastructure to become smart and autonomous. And this means that it will reduce the need for human intervention and also extend the life of the assets at the same time. So we've also developed an innovative commercial model as well. So with one investment in the sewer system, you make both the sewer system and the fiber networks in a city more resilient. The sensory containment can be funded through an infrastructure investor, and we've suggested a kind of asset vehicle model here. And what this means is that then water companies can take monitoring as a service and pay for it when they are receiving the benefits. And then a fiber infrastructure or service provider can lease infrastructure here and then be able to incur the cost when they're actually able to connect customers to their network. And that reduces the cost and risk for both parties so they can share the benefit. So our system offers both sensing and networking at the same time. And it means that it provides the vital multi-parameter wastewater monitoring data that is required to responsibly manage our sewer systems, transform performance, and also enable a true systems approach to the management of our water networks as a whole. But the networking then offers the opportunity to provide a reliable data platform to network in other water sensing capabilities. For example, intelligent pumps and valves, intelligent cleaning, chemical sensing. And these things are going to become more important. And we already have intelligent pumps and valves, but sometimes the data on them is throttled back or not used because it's costly or uses up too much in terms of battery power to actually take all of the data that they would actually want. But this will unlock that by actually being able to plug them into a real fiber network. And also the fiber is vital for intelligent operation as well. And the networking can also then provide a fiber backbone required for 5G and smart cities, making the sewers an even more critical infrastructure within a smart city environment and providing even more benefit. So I'm conscious that this presentation has, really centered around Nuron's technology, but really it's about what's the next level potential of smart sewers, and I guess Nuron's technology is one way to achieve that, but I'm sure that there will be others. So I thought I'd leave you with some more general thoughts on actually smart sewers. And here are two things that I've found that have really resonated with me. There are lots of people doing some really good work in the smart sewer space, and here's one of them, and there's a link there, so you can go and click on that later. I think both of these things are really interesting and worth looking at. So one is that Swan have developed a really useful framework for achieving smart sewers and water in general. It could be used across both. But the thing that really struck me was actually coming from a communications background. The collection of data and the communications piece is really squarely within that thinking. And I think sadly that's often an area that's really taken for granted because they think it exists already, and therefore really overlooked in actually making the most of gathering and using all the data that's available. So it's really important to get the right connectivity for the right data application. And the other is from the Ultimate Water Project. The Ultimate Water Project is looking to create economic value and increase sustainability by delivering value from the resources within the water cycle. And I thought that what was really interesting is this shows wastewater is central to the water nexus and the circular economy in water. And I really think that it's time that people started paying more attention to this undervalued resource that is running silently, hopefully most of the time, through our cities. So that's where I was going to leave this today. Here are my contact details if you have any questions after the event. But I think I'll hand back to Tak and see if there are any questions.
All right, thank you very much, Claire, for the excellent presentation. It's impressive, actually. It's not necessarily the cutting-edge technology, but using the fiber optics very smartly, we can create a circular economy and very efficient operations of the infrastructure. And also, we can maintain the longevity of the infrastructure. Good ideas. Thank you very much. And for viewers, this is the time for making comments, asking questions to Claire. So please use the chat box to send your comments or questions. I'll pick them up and ask Claire to answer. All right. So until we get the questions from the audiences, let me ask you some questions. So this time, the presentation usually focused on the sewer side. But what about the clean water supply side? Can you apply same technology to water supply side?
You absolutely can, and other people have started to develop solutions for putting optical fiber through networks. In our view, we decided to start with wastewater because we felt that there was the biggest need there, and there are already different types of monitoring on the clean water network, and as well because water networks are pressurized, point sensors work more effectively. Whereas the sewers with the open flow environment there, they're a bit like rivers, they operate like rivers. So actually understanding what's happening at one point in the river doesn't really necessarily tell you what's happening somewhere else along the river because of what might be added along the way. And so that's why we've decided to do it, but there's definitely work in progress. And we have also, again, in our development pipeline, a clean water monitoring system that could be networked into the fiber platform to make, again, a really efficient way of monitoring without the need for batteries, but using the same core technology.
I see. Yeah, I have some times visit the rural Japan, regions of Japan, and sometimes I hear from the city councils water is leaking somewhere in the pipeline, but don't know where. So if you have to dig the ground to find it out, it's so costly and almost like wasting a lot of money. So there's no way than just leaving it out until more severe damage occurs visibly. So if you can implement this fiber optics in the water supply in the regional area where the population is decreasing, that's the key point. We can maintain the water supply infrastructure without costing too much, and it must be appreciated by the city councils and citizens, I guess.
Yeah, I mean, I think that would be really helpful, because I think that, I mean, people, it's funny because we all concentrate on where we're building new cities or bigger cities, but we don't really think about the assets that potentially still need monitoring and need to be there, but with less oversight and insight. And really, for me, smart sewers is actually a lot about allowing assets to be to have automation and visibility of them without the need for human intervention, and only to go there when absolutely necessary. So I think it can really help, because if a sewer system fails, it can be quite catastrophic. It can you can have road collapses, you can have big disasters, which really need to be avoided to protect people.
Yeah, exactly right. In the existing cities in Japan, in the urban area or regional settings, anyway, we have to dig the ground to maintain the sewage or electric pipeline or internet pipeline. And then it's a case of Japan, but you see somewhere always digging the ground.
Mm-hmm.
One day they're fixing water pipeline. The other day they're digging same place to fix the sewage. The other day they're digging again the same location for fix the electric the lines and so forth. And it's so a waste of the money and a waste of the time. And if you can monitor everything with the fiber optics, it's going to be more systematic. So in addition to just sewage, maybe we can have a combined pipeline running under the ground, and with the fiber optics setting up by default, so we can see many things at the same time. Is that possible?
I think so. I mean, and I do think, I absolutely think that I have lots of ideas for greenfield. If I could get my hands on a greenfield project, and how would we set up the utilities and the infrastructure and make sure that you have the right data collection? I mean, I think that that's where smart infrastructure needs to move to. New standards, but not just about how you build them, but actually what data and information you must collect and have all the time they're in operation, because that's the only way we're going to move from where we are today to really, I guess, really smart infrastructure, I think. But I think that's absolutely possible, because we are also looking, so our from developing this technology, we have quite a unique skill set. So we are experts in optical sensing, but also fiber network deployment, and the fiber platforms that you need to integrate lots of assets from our communications background. And we are working in other sectors like gas and electricity, and looking at, again, how optical monitoring techniques can be advanced to deliver more value for these people, using what's great about the potentially electricity industry, for example, is they're already using optical monitoring, and they already have fiber platforms for their own use for a lot of things. And so it's then about how much more can it do for these companies that's in place. So there's definitely a place for distributed acoustic sensing across all utilities, I think.
Okay, thank you very much. And one kind of question that came across my mind: if you think about Japan, there are lots of earthquakes. If you can sense the earthquake through the fiber optics, it's going to be new eyes to sense and monitor where and in what magnitude we have the earthquake in Japan.
Yeah.
How can the fiber optics sense the kind of vibration of the land to sense the earthquake? Is that possible?
So yes, I mean, I think that using the sewers, you could sense the earthquakes, but I suppose also importantly for the sewer, you could monitor the damage as well that occurs, where it occurs, and so from where the epicenter is, where does the most damage occur, etc. But I imagine that also you're just using your communications networks. If you were to use distributed monitoring across those, you could also get it's really interesting earthquake data across that as well. So yes, I think it's got multiple purposes. But yeah, I forgot to mention that actually I thought a really good use case in Japan would be monitoring the sewer assets for earthquakes. And also I saw that in Japan you've developed sort of earthquake resistant sewer pipelines as well, and really being able to monitor the performance of them and see how well they hold up would be really interesting as well.
Okay, thank you very much. Maybe implementing this fiber optic system is very much attractive for the city council, because it's going to reduce the monetary burden to maintain the infrastructure. Maybe even reducing the insurance cost in case of the damage of the infrastructure. So it's interesting. Maybe we should introduce this system to some of the cities, so they may be interested. Right, and some cities are also active in exporting smart city modules to Asian countries, where the greenfield smart cities are started to be built. So packaging this product with the other, basic infrastructure modules of cities, we can sell this product as, essential product as by default to let's say Asian smart cities projects. Never thought about it, but just instantly that popped up in my mind.
But yeah, I mean, I would love to work on a collaboration of a greenfield smart city, and actually, obviously looking at the sewer piece, but also looking at all of the infrastructure and how you would really start to deploy really smart infrastructure.
Yes, in the countries like Thailand, there are 100 smart city projects are going on. In India, they say 100, but I think it's 1,000 smart city maybe constructed because of the sharp population increase. And any other Asian city countries like Vietnam, Philippines, Indonesia, there are lots of smart city projects are ongoing. So there must be a lot of opportunities going forward. And right, let me ask you your potentials or your willingness to expand overseas. How far did you go? In which countries have you already implemented this product outside of UK?
So we've only actually installed in the UK so far, but we're developing partnerships in America currently, and in parts of Europe as well. So that's where we're looking to scale our technology. And also, as part of this, we have a real interest, as you were talking about, the smart cities market in Asia, and also just the Japan is of real interest to us, because you seem to be at the forefront of technology, and you're also already very advanced in what you're doing in terms of smart sewer technology. And we feel that what Nuron will bring to Japan is the next level of smart sewer systems, really.
How do you establish the foreign presence? Through a joint venture, or just a partnership, or export only? What's the expected course of action?
We're small and flexible, but at the moment we've been looking at at joint ventures, but the joint ventures could be that we form a presence and we grow a joint venture that can actually deliver and operate and maintain the technology. and it could be purely licensing as well. But at the moment, it's mainly the former that we've been talking to people about, in terms of finding a partner who we can train up and develop the capabilities with together to exploit in the country. And that will bring, jobs, new skills, completely new technology and skills. And I also think that I don't know if it's the same in Japan, but one of the challenges that we've had in the UK is keeping young people in the water sector, making it exciting enough for them to remain in the sector. And I really feel that the data sets that this could bring, and the digital transformation would be very exciting for the next generation of people coming through.
I see. That's a good point. Attracting younger people to this business is very important also in Japan. And that leads my mind to the question about the interrogator. You talked about the brain attached to the fiber optics. How does it work? Is it like an AI system, or how do you judge that something sensed through the fiber optics? What's the work of the interrogator?
So the interrogator, as Paul kindly told us earlier, it's a laser. So it shines a laser pulse through the system, and it measures the backscatter of light from the impurities in the fiber. And what it's looking for are changes in the backscatter, and it converts, and so that then gives us optical data that we then use algorithms that we've developed to then translate that into operational parameters like flow and depth, and temperature is an inherent measurement that can come out of the system as well.
Okay.
Yeah.
Okay, thank you very much. And let's move on to some of the comments or questions coming from the audiences. I'll read them for you. First one is from Matsubara-san. In Japan, earthquake is quite common, and I think sometimes sewage pipes are damaged. The optical fiber network along those pipes are tough, resilient enough to survive such disasters.
So I mean, that's a really good question. I think it would depend how much the sewer pipe has broken around it. But what it will tell you is, I mean, even in the most extreme case where the sensor is broken, even, it will tell you where it's broken and where you need to go and fix it because the sewer is broken. But I actually think that, I mean, we have designed it to be incredibly tough and resilient, and and fiber is pretty tough and resilient as well. But I guess we would have to, I think if it's been designed to withstand general challenges within the pipe. But I think that if you had a catastrophic failure of a pipe, I don't know if the sensor would survive or not, but it would definitely tell you exactly where the main issue is and where to dig, if that makes sense.
Yeah, makes sense. All right, thank you very much. The next one is from Kudo-san in our organization. Now, this is a kind of typical question. Thank you for your great presentation. What do you think is a challenge if you would like to do business in Japan? Maybe language barriers or regulations, cultural differences. What do you think is the most critical challenges for you?
The most critical? I actually feel that, I mean, potentially language barrier is one of them. But I actually feel that it's the similar doing in business in most other countries. Finding the right partner, I think, is the one that is really critical to actually making it a success. And so to me, that would be the most critical challenge to overcome or to solve to make it a success.
What's the kind of expected partner look like? Is it the company is doing somewhat related business with the sewage, or universities, or the city council? What do you think is the most preferred type of partner in Japan?
So we the types of partners that we've had most success or most alignment with are usually either operators of concessions for municipalities, or purely operators or owners and operators of assets, of wastewater assets, typically have been the best partners, where they're actually, you know, they actually have a field force, they do work on the ground as well as manage the assets as well, because they're really firmly aligned to, you know, to wanting to see and drive these operational efficiencies and changes, and really maximize the value that they can get from wastewater as well.
Probably there are two typical types of potential partners for you in Japan. One is the public corporations taking care of the water management, wastewater management, run by city council or any public entities. Second is the private companies supplying the components or parts of the water management systems, like a Kubota, or, you know, maybe those companies. Yeah, maybe today we don't have time to cover those in detail, but maybe you can come back and have a session with the Japanese expected audiences in a more closed session to talk about whether or not they are interested in your business.
Okay, thank you. Yeah, this is not the purpose of today.
We run so-called online salon, inviting the member companies and you know, public entities to this online environment to you know, face showing up and talking to each other in a bilateral way. That's maybe the next step to take.
Oh, thank you for the advice.
Right. And the final question is from Yokoyama-san. Smart cities value integrating data from different sources to create values. Is there a potential to combine wastewater data with other data to create smart solutions?
So I mean, I think so, absolutely. So you know, for example, I was talking about a use case for COVID monitoring. And so, you know, actually, you know, taking samples of that. Someone was telling me of, I was talking to someone from Aquafin in Belgium, the CEO Jan Gossen, and he was talking about a use case in Belgium where they're monitoring now the pH of the sewer, because that can help them detect drug farms, because when a drug farm sets up, it changes the pH of the sewerage. And things like that. But also, I think the biggest opportunity here is combining it with the clean water data initially, to really understand the full water cycle and how that's integrating together. Because I think that there's nothing that really drives people to save water, but really understanding the cycle and the impact that actually maybe having more grey water techniques and removing rainwater and things from the sewer can really, you know, significantly help in terms of water scarcity, but also in terms of reducing the cost of building new capacity and coping with climate change. And I'm sure, as anyone who works with data knows, that once you've got the data, you just find more and more, you know, you just find more and more use cases with what you combine it with in terms of what can be done.
Right, thank you very much. And we cleared all the questions and comments from the audience. And I just want to say thank you for including Japanese cases in your presentation materials. You know, the Osaka Castle, Kanda sewage, and G-Ken storm drain, which is also a, you know, interesting example. Thank you for kindly including our cases in Japan. All right, let's invite Mr. Phillip White for his comments. Phillip, would you come in? Yes.
Thank you. Sorry, I was just clicking there. Thank you very much, Claire, for a fascinating presentation, and Tak and the audience, thank you for the questions. I was just doing some research on this, and I understand that there have been some developments already in Japan with optical fibers down sewers, but having several point sensors. And there's a trade association called SOFTA with a number of members Some companies you'd naturally expect are naturally in the fiber business, but they use the optical fiber with a high power laser beam to send that as a source of power to a number of point sensors in the sewer, where they convert the optical power to electrical power to power individual point sensors. And there's a network, I think it was something like over 2,000 kilometers of optical fiber already in the sewers. So I suppose an interesting question for Claire is, would it be of interest to perhaps collaborate with members of this trade association? And the most interesting thing, I suppose, is it possible to apply your sensor unit to another fiber that was intended to be delivering power, and just to see whether you can get signals just by connecting your module to existing fiber? I suppose you don't know until you actually try it, and it depends on the spec of the fiber. But is that something that might be of interest to you?
I'd very much have to see, because yeah, it just depends what kind of fiber and how it's packaged, because obviously how we've packaged the fiber, you know, really make sure that it can actually sense the changes that we're looking for. But I'm always interested to learn what people are doing, you know, in different spaces, because, you know, there's always something that you can glean from it one way or the other. So yeah, I'd definitely be interested. What trade association is it? Sorry?
I'll send you some information, but the website is in Japanese, softa, softa.or.jp, and I'll send some information about some Japanese companies that are already working in this project, and happy to have a chat separately and talk you through some of this Japanese website.
Yeah, no, that'd be great. No, it sounds really interesting. And power in the sewer as well would be, you know, as I said sort of earlier, an amazing advancement if that's possible. Often it's usually not advised because of the potentially explosive nature of the gases. Yeah.
Yes, that's a good point. So if there's an existing duct that this fiber has been put down, then could that existing duct be useful for you? Or do you need the fiber to actually be in the water?
It can be useful to monitor some things, but probably not the operational parameters such as flow and depth. But it could be useful to monitor structural integrity and potentially temperature, maybe. But yeah, it very much depends on the location and things.
So then that prompts me just a detailed question. So one of your fibers is preferably in the water. So is that blown, or does it have to be drawn, or does somebody actually have to go down there?
So that's the robotically installed containment system that we put in.
I'm forgetting.
So it's bonded to the base of the pipe, but designed to sit in the flow. But it effectively remakes the bottom of the pipe, so it's very smooth and ragging free. Yeah.
I'm forgetting about Oscar.
Yeah,
thank
Oscar.
you. Now, that was all I had to ask. Thank you very much. Fascinating presentation. I'm sure there's tremendous potential for this.
Thank you.
Thank you very much. Thank you, Philip, for insightful suggestions and comments. And maybe could I also ask Mr. Richard Lewis for the final comments to conclude this session?
All right, thank you very much. Like I say, you just heard from Nuron, one of the very innovative UK companies that is helping transform old infrastructure into something sort of more dynamic for the modern age. So yes, do continue to connect with us, and thank you for giving us the opportunity to present today.
Thank you very much. Okay, I think it's right time to conclude our session today. So Ms.Claire Fenwick, Mr. Phillip White, Mr. Richard Lewis, thank you for presenting with us. And this concludes our session. Thank you very much.
Thank you very much.
どうもありがとうございました。
ありがとうございました。工藤さん、よろしくお願いします。
はい。Claire, Mr. White, Mr. Lewis, thank you very much for speaking at our webinar today. And also for the viewers, we would like to thank you for staying with us. And I also would like to say thank you to Arai-san from British Embassy in Japan, who kindly introduced, Claire, Mr. White, and Mr. Lewis to our webinar. So thank you very much. Let me just put up my presentation screen. Yes, so thank you for viewing today. And we have a questionnaires after this event. So we would ask you, if possible, to answer these questionnaires for the future improvement of our webinar. And our webinars will be available on Smart City Institute's Twitter, Facebook, and LinkedIn. And also videos, including past videos, and today's video will be posted on SCI Japan YouTube channel. And our future programs, let me introduce two next week. So tomorrow is a national holiday in Japan, so many of you may be taking a day off. And next Wednesday, we have a so-called monthly pitch 7 minutes. This is an online matching event with local governments and startup companies in Japan. And this is going to be our 7th series. So please come and join us. And also on Thursday, under the series of Well-being of Planet Earth and Citizens. This is a very popular series. And we have a lady from Asia Pacific Initiative, API, a fellow, Ms. Jun Mukoyama here. And why policy entrepreneurs are attracting attention now. So this is the topic. So both of them are in Japanese. And if you are interested in, please join. And also a little bit about Smart City Institute Japan. We were established back in 2019 October. And also our members are growing, and we have about 419, close to 500 now. And we have global partners organizations in UK, including British Embassy Tokyo today, and also Greater London Authority, as well as Connected Places Catapult, which may be familiar to Mr. White, Mr. Lewis, and Claire. So again, thank you very much for joining us today. And I hope that you have a very nice weekend, as well as looking forward to see you back again next week. So thank you very much.
Thank you very much. See you again.
Thank you.
Thank you
Bye-bye.
very much.
Thank you.
Thank you.